Spray foam costs $4 a square foot. Installed, a bag of recycled denim insulation costs $40 and covers 40 square feet of wall cavity at R13. That gap is the whole story. Nadia Voss found out about the denim bats the same way she found out about most useful things. Not from a store, not from a contractor, not from anyone who had a reason to tell her. Or she found it in a dumpster behind a building supply warehouse on Southeast Powell, Portland. Late October, temperature already dropping to 38 at night. The bag was torn at one corner. The label read, Ultra Touch Natural Cotton Insulation. She didn't know what that meant yet. She carried it 6 blocks back to the row house and set it against the wall she'd been sleeping next to, the wall that radiated cold like a second winter happening, 3 inches from her face. That was the beginning. The row house sat at the end of a dead stub of Industrial Street in the Foster Powell neighborhood, one of those pockets that hasn't been bought yet. Not fully. The kind of block where a shuttered auto upholstery shop shares a fence line with a vacant lot full of broken pallets and a half-demolished brick structure that someone started on and stopped. The row house itself wasn't condemned in any official sense. There was no notice on the door didn't lock anyway, and the city hadn't gotten around to it or didn't care, or both. 3 other people had used it at different times. Nadia moved in September after she lost the room she'd been renting in a house on Holgate. The house sold, 4 weeks' notice, $50 returned of a $400 deposit. She had her pack, a sleeping bag rated to 20 degrees, a plastic bin with a lid, and whatever she'd been able to carry in 2 trips. The row house had walls. That was the thing about it. 4 of them. A ceiling, a floor with 2 soft spots she learned to step around. Windows on the street side that still had glass, which meant wind wasn't the problem. Cold conduction was the problem. The walls pulling heat out of whatever space she'd managed to warm with her body and breath. She'd wake up at 3 a.m., and the air inside was 41 degrees. Her sleeping bag handled that, but only if she stayed inside it. The moment she sat up, the cold started. The moment she stood up, the cold was immediate. Getting dressed in the morning meant doing it fast, inside the sleeping bag, which is its own kind of problem when you're trying to put on jeans. She knew the walls were hollow. She'd pressed her palm against them and felt nothing. No fill, no resistance, just the outside air pressed up against the inside of the drywall. In a house like this one, built probably in the 1940s, there was no insulation in the walls at all. It was never required. The wall cavity between the interior drywall and the exterior sheathing was just air. 3.5 inches of air that moved and carried cold directly inward. She hadn't thought, before that October, that this was something she could fix. Insulation felt like a contractor thing, a permitted thing, something you paid for and had installed. It wasn't in her frame of what she could do herself, in a building she didn't own, with materials she didn't have. The bag changed that frame. She read the label in the dim of the row house with a flashlight she kept in the side pocket of her pack. Ultra Touch Natural Cotton Insulation. R13. Formaldehyde-free. Made from 80% recycled denim. The bag was rated for 2x4 wall cavities, 15-inch width, 93 inches long per bat. The bag held 8 bats. She counted them. All 8 were intact. The tear in the bag had happened at the seam, not through the insulation itself. None of the bats were wet. She pressed one between her palms and felt it. Dense, soft, not like fiberglass at all. No itch, no need for gloves. She held it against the wall, and it stayed. Friction fit, no adhesive, no staples. The 3.5-inch cavity was made for exactly this width of bat. She stood there for a moment, with one hand on the bat, and thought, how many cavities does this wall have? She counted studs. In a standard 2x4 stud wall built before 1970, the framing is typically 16 inches on center, meaning the space between studs is 14.5 inches wide, and the bat is 15 inches wide, so it compresses slightly and grips. She had 8 bats. Each bat covers one cavity the full height of a standard 8-foot wall, or 2 cavities if the wall is shorter. The row house had 9-foot ceilings, 8 bats, 1 per cavity. One wall almost fully done. One bag wasn't enough, but one bag was what she had. She put all 8 bats into the wall she slept against, the north wall, the one that took the worst of the wind off the street. She worked cavity by cavity, pressing each bat in from the interior side where the drywall had come away from the studs in places, or where there was no drywall at all, just the lath and plaster blown through in one corner. Where the wall was intact, she made cuts Not with a box cutter which compresses the fibers and drags, but with a long bread knife she had in her kit, a serrated blade that moved through the denim cleanly. The bats went in friction fit. No gap at the top, no gap at the bottom, no gap at the sides. She checked each one with her palm before moving to the next. You can feel the cold spots if there's a gap. The cavity pulls heat right through. That night, she slept differently, not warm, not comfortable in any conventional sense. But the wall behind her head stopped being a cold surface and became neutral. It stopped taking. That was the change. Not warmth added, cold removed. She needed more. This is the part that has an access problem, and the problem is not obvious until you need to solve it. Denim insulation is available at Home Depot. A bag, the same size, same R13, same bat dimensions, runs $55 on the shelf. That's $55 she didn't have. And even if she'd had it, walking into a Home Depot with a 30-pound bag of insulation and no address to deliver it to, no truck, no storage, puts you in a position of moving heavy material through a city on foot. There's also the question of volume. To insulate all 4 exterior walls of a room roughly 12 by 14 feet, with 9-foot ceilings, she needed approximately 28 bats, 3.5 bags. That's $192 at retail. That's not possible on a week that started with $11. The dumpster was the access point, and it wasn't luck. She went back. 3 nights running, she went back to the building supply warehouse on Southeast Powell after close and checked. The first 2 nights, nothing. The third night, 2 bags, 1 torn, both full, same product, dry. She took both. She came back the following week and found 1 more bag, this one with a crushed corner where a pallet had been stacked on it, but the bats inside were fine. In 6 weeks, between Powell and a second warehouse she found off SE 17th, she accumulated 26 bats, after she was 4 short of finishing all 4 walls. For those 4 cavities, she used a different material. She'd been watching what came out of the textile donation bins on Division, the ones that take fabric too worn to resell. Or she'd asked the attendant at the drop-off once whether anything came out the other side, and the attendant had said yes. A hauler picked it up, and no, she didn't know where it went. What Nadia noticed was that certain bins had overflow, bags left beside the bin when the bin was full, bags that weren't collected before the next load came. On a Tuesday in November, she took 3 large garbage bags of textile scraps from an overflow pile and brought them back to the row house. What came out of those bags? Old jeans, mostly, some sweaters, a few lengths of canvas fabric. She opened all 3 bags and sorted by material. Denim separated, everything else in a second pile. After she had enough denim, the legs and body panels cut from jeans to pack 4 wall cavities, not in bat form, in loose fill. She pushed it in section by section, compressing each section with her forearm before adding the next. Loose fill in a wall cavity doesn't achieve the same R value as a friction fit bat. A tightly packed cavity of denim scraps probably gets to R9, maybe R10. That's less than R13. But it's not nothing, it's significantly not nothing. The 4 cavities went in on a Saturday. She finished the last, one around 4 p.m. when the light was already going. The difference between before and after is something she noticed across the first 3 days, not in a single moment. The mornings are where you feel it. At 6 a.m., the air inside used to sit around 39 or 40 degrees, regardless of what she'd done the night before, regardless of how long she'd been in the sleeping bag, regardless of whether she'd heated water before bed. The walls were just moving cold into the space continuously, a slow bleed, and the space never got above ambient outdoor temperature by more than a few degrees. Because the heat she generated, body heat, breath, was leaving through the walls as fast as she made it. After the walls went in, the mornings changed. Not dramatically, she doesn't want to make it sound like the room became a warm place, because it didn't. But the air at 6 a.m. was sitting at 47, 48 degrees instead of 39. That's an 8 to 9 degree difference in resting air temperature with no additional heat source. Just the insulation. Just stopping the walls from taking. For context, the difference between 39 degrees and 47 degrees when you're getting dressed in the dark is the difference between dreading it and just doing it. That's not a small thing. She tested it without the sleeping bag. One night, lay on her mat with 2 wool blankets, the sleeping bag unzipped and laid over the top. Outdoor temperature that night dropped to 34. She woke up at 2 a.m. Cold, but manageable cold, not crisis cold. The blankets were enough. Before the insulation, That same setup would have had her up at midnight shaking. She'd used spray foam before, in a different situation, a different structure, a gutted storage unit building in Southeast that a group had been in for a few months in 2022. Someone had a can of great stuff. They'd sprayed gaps around the windows, the door frame, anywhere. Air was moving visibly. The foam was good for air sealing. It stopped drafts. But it didn't insulate mass. It filled cracks, not cavities. Or a window with foam around its frame, and nothing in the wall next to it is still a cold wall. The foam addressed one problem and not the other. The other thing about spray foam in a cavity, it's not really a DIY wall cavity product in standard single-component cans. The great stuff cans that are accessible are for gaps, 1/4 inch to 3-inch gaps. Filling a 14.5 by 93-inch cavity with spray foam requires a 2-component kit, which runs $350 to $600 per kit, and requires protective equipment, ventilation, and immediate work before the foam sets. That's not a realistic option for someone working alone in an unvented space with no running water for cleanup. The denim goes in with your hands. It sits there. It doesn't off-gas. It doesn't expand and crack the drywall. If it gets damp, which can happen in a structure with no vapor control, it doesn't lose structural integrity the way fiberglass does. Denim insulation can absorb up to 15% of its weight in moisture and still maintain roughly 85% of its R value. She didn't know that statistic when she started. She learned it later from a building science PDF she found on a library computer. But she'd noticed, after a wet week in November, that the bats in the wall didn't smell, didn't sag, didn't seem to have changed. Fiberglass, when it gets wet, mats. It loses loft and loses R value. Denim doesn't behave that way. There's something specific about working with recycled denim that's different from working with any other insulation material, and it matters more than the technical specs. The material is soft. You can handle it for hours without gloves, and your skin is fine. You can cut it on the floor, push it into a cavity, smooth it into corners with your fingers. It behaves like something made to be handled, which it was. It was clothing first, before it became insulation. The manufacturing process shreds the denim into fibers and rebonds them with a small amount of polyester binder, which is how it holds its shape as a bat. But the fiber character is still there. You can pull a bat apart with your hands if you want to, reshape it, push it into a corner that isn't quite the right dimension. She had 3 cavities that were narrower than standard, partial bays near the corner framing where the stud layout shifted. Standard bats don't fit those without modification. Where she pulled the edge fibers of each bat outward, not cutting, just separating, until the width matched the cavity, pushed them in. They held, no staples, no tape. The friction is real. The material wants to expand to fill the space it's in. This isn't how a contractor would do it. A contractor would pre-cut with a utility knife, measure twice, keep edges clean. Or what Nadia did was faster and worked in the same way, just less tidy at the edges, which don't matter once the wall goes back up, or in a wall that has no finished surface, as several of hers didn't. By December, she had a system. Every week, she checked 2 dumpsters and 1 textile overflow bin. Not every week produced something. Some weeks, nothing. A good week, a partial bag of bats, or a full bag of denim scraps, or both. She started prioritizing the north and east walls because those were the exposure sides. West wall was interior to an adjacent structure which muted the heat transfer. Her south wall had the least cavity run because that's where the door was, where the window was, where the longest uninterrupted stud bay was only about 6 feet before a header broke it. She kept a rough tally on the back of a card she kept in her bin. Total cavities in the 4 exterior walls of the room she used, 34. Cavities insulated with bats, 22. Cavities filled with denim loose fill, 8. Cavities still empty, 4, all on the south wall near the window framing, awkward shapes she hadn't found the right material for yet. The 4 empty cavities were near the window and she addressed them differently. She found a roll of closed-cell foam backer rod, the kind used to seal expansion joints in concrete, also called caulk backer, a soft cylindrical foam rod that comes in diameters from 3/8 inch to 2 inches, in a construction dumpster off Milwaukee. She cut lengths of the rod and pushed them into the window-adjacent cavities, layered until the cavity was packed. It's not R13. It's not even close. But the air sealing effect, no air movement through those cavities, was better than nothing by a significant margin. Air movement through an uninsulated cavity is worse than a static air gap because moving air carries heat away faster than still air. Stopping the movement was the first priority. R value was secondary. By January, she had all 34 cavities addressed with something. The coldest night that winter in Portland was January 17th. The temperature downtown hit 19 degrees Fahrenheit. Not a common temperature for Portland, but not unheard of. A hard freeze. Where she was in the row house, she had the sleeping bag, 2 blankets, and the insulated walls. After she woke up once at around 4 a.m., the air in the room was 43 degrees. Outside was 21 degrees at that hour. A 22-degree differential between inside and outside maintained passively, with no heat source except her own body. She's not going to claim this is the same as a heated apartment. It's not. 43 degrees is still cold, you still feel it. But 43 degrees is survivable in a sleeping bag with blankets. After the nights before the insulation, with the same setup, the room would have been sitting at 22 or 23 degrees, essentially outdoor temperature, because the walls were conducting without resistance. That night, without insulation, she would have been in danger. With insulation, she was cold and okay. That difference is the entire point. What made the denim work over foam, for her situation specifically, was not just the R value, it was the access. A foam is accessible if you have money and a vehicle and a project with clear geometry. Denim scraps and discarded bats are accessible if you know what buildings throw them out and when. Access is the constraint. It's always the constraint. The insulation product that exists at a hardware store is not relevant to someone who cannot get to a hardware store and pay for what's there. The product in the dumpster behind the hardware store is the one that matters. This is not a design flaw. It's not a supply chain problem. It's just how material moves through a city. Excess material enters the waste stream at predictable points. Building supply dumpsters get surplus and damaged goods. Textile donation infrastructure produces overflow. Demolition sites strip materials that are still functional. The person who knows where these streams are has access to materials. The person who doesn't. Nadia spent the first 3 weeks in the row house knowing the walls were a problem and not knowing what to do about it. The bag in the dumpster on Powell closed that gap, not because denim insulation is a secret, not because building supply companies are hiding it. It's not a hidden thing. It's available at Home Depot. What's hidden is the part where someone tells you, this is a thing you can do, here's what to look for, here's where it ends up when it's surplus. That part doesn't circulate. The other thing she learned, the thing she wasn't expecting, was what the walls felt like after. Before, she didn't think about the walls. They were cold surfaces, a feature of the structure, like the floor or the ceiling. After, she started noticing them the way you notice a window when you're looking through it, instead of at it. The wall stopped being something she registered. It became neutral. It became background. There's a specific experience of being in an under-insulated space that most people who have only lived in heated buildings don't have a framework for. It's not quite like being cold. It's more like being continuously drained. The space pulls from you slowly, and you're not fully warm at any point, even when you're warm enough. You're running a deficit always. The insulated walls didn't make the room warm. They stopped the deficit. She could sit in the room and just exist in it, instead of sitting in the room and losing heat to it. That change happened across 3 or 4 days in November. She noticed it specifically because she'd spent a day in a library, heated, obviously, and came back to the row house expecting the contrast to hit hard. And it didn't hit as hard as it had before. The room had retained some of what had been in it. Not warmth, stability. That's the word she'd use. The room became stable. She started talking to people about it, not formally, not as a presentation, just when the situation came up. Someone at a day center who was trying to figure out a situation in a structure off Burnside. Someone she knew from before who was in a different part of the city dealing with the same problem of cold walls and no budget. She told them what to look for. Building supply warehouses with open dumpsters, specifically ones that do renovations or flip inventory at end of season, which in Oregon is late September through October when contractors finish summer builds and return or discard surplus. She told them the difference between fiberglass, itch, gloves required, not worth it from a dumpster because damp fiberglass is useless, and denim, which handles wet without losing its character. She told them about the textile overflow bins. She told them about baccarat as a secondary fill for awkward cavities. None of this is a formal system. She's not running an organization. It was just, she had learned something by being in a specific situation at a specific time. And she told people who were in similar situations, because that's what you do when you find something that works. By February, the wall situation in the row house was effectively finished. She wasn't adding anything. The cavities were full. The mornings were consistent, 44 to 48 degrees when outside was in the 30s, lower 40s when outside was near freezing. The sleeping bag, 2 blankets, and the insulated walls formed a thermal system that held through the night without additional input. For she had one other modification she made in February that's worth mentioning because it works in combination with the insulation in a way that matters. The window on the north wall, single pane, original glass, the kind that's practically not there from a thermal perspective, was losing as much heat as 3 or 4 insulated wall cavities were retaining. Their single pane glass has an R value of approximately 0.9. The insulated wall cavities she'd built had an effective R value she estimated at somewhere between R10 and R13. The window was undoing a portion of the work. After she covered it, not permanently, she still needed light. She cut a piece of rigid foam she'd found, a 2-inch piece of polyiso from a construction debris pile, to fit the window opening. During the day, she propped it to the side. At night, she set it in the opening. The polyiso at 2 inches gives roughly R12. Combined with the insulated walls, the room's thermal performance at night was dramatically different from what it had been in October. She didn't measure it with instruments. She measured it with sleep. There are some things the denim insulation didn't solve. The floor, an uninsulated floor over an unconditioned crawl space, which this one had, open lattice at the base of the structure, cold air moving freely underneath, loses heat differently than walls. The bats that work in a wall cavity don't work in a floor without a support structure, because gravity pulls them out. She addressed the floor differently, and it's worth being honest that the floor solution was less effective than the walls. She layered cardboard, flat, overlapping, 3 layers, across the floor area she used, and then put a canvas tarp over that. Cardboard has an R value of approximately R.7 per layer. 3 layers, about R2. Not the same, not close. The floor stayed cold. She wore wool socks and didn't spend time sitting on the floor. The door was a significant gap, an exterior door with no weather stripping, a 1/2-inch gap at the bottom. She addressed that with a door snake, a fabric tube filled with dried rice, which she'd made 2 years earlier for a different situation and still had. The gap at the bottom accounted for more heat loss than she'd have expected. After the snake went down, drafts across the floor stopped. These are not complete solutions. The walls were the part she solved fully. The floor and the door were partial. She's not going to say the room became comfortable. She'll say the room became livable through January in Portland at a temperature that without the insulation would have been dangerous. The walls, the floor layers, the door draft, the window insert at night. These 4 things work as one system, and none of them fully works without the others. A well-insulated wall with a single pane window and a drafty door is still a room bleeding heat. A covered window and a sealed door with uninsulated walls is a room that holds air but not temperature. You have to address all the surfaces. Not equally. The walls are the largest surface area and the highest priority, and the walls are where recycled denim insulation changed what was possible, but the walls alone weren't the whole answer. The whole answer was walls first, because that's where the most heat was going and where the most accessible material fit the problem. Then the secondary surfaces, with whatever was available and worked. Not elegant, not permanent, or functional through the worst months of a Portland winter, in a structure that had no business being anyone's shelter and was, for a period of time, exactly that. Nadia Voss moved out of the row house in March, when the city finally put a notice on the door. She had 9 days. She took the sleeping bag, the bin, the door snake, and 2 of the denim bats she could reach without pulling the wall apart. She left the rest in the walls. They'll be there until someone guts the place, which might be soon and might not be for years. When she found the next place, she already knew what to look for in the walls.